Good morning, one and all. I am T. Gayatri, an associate professor from Department of ECE at Reddy College of Engineering and Technology. I am going to deal with microwave engineering subject. This subject is for final year ECE students in first semester. Now, I'll go to my subject. This is the topic number 1, Introduction to Microwaves. The course objectives of this subject are to outline the concepts, importance of microwave frequencies, rectangular waveguides and microstrip lines, to explain about waveguide components, to classify microwave tubes, and to describe different microwave M-type tubes, to analyze frequency, power, VSWR, attenuation using microwave bend setup. Upon completion of this course, these are the course outcomes. The students will be able to summarize the concepts of microwave frequencies, interpret the applications of waveguide components, to categorize microwave tubes. They can explain the working of magnetron and gun diode. They can examine the frequency, power, VSWR, attenuation using a microwave bend setup in microwave lab. Now, coming to the subject, what is a microwave? Microwave is a small wave, a tiny wave, a really small wave. It is a microwave. Why it is so small? Because the frequency is in the range of 1 gigahertz to 1000 gigahertz. As the frequency increases, we know that the wavelength lambda decreases. Now, if we calculate the wavelength of this microwave signal, it will be in the range of 1 foot is the maximum wavelength and the minimum is 0.3 mm, which is very small. So that's why it is known as microwave. The characteristics of this signal is they are heat generating waves. So this heat generating characteristic has many applications. The wave at higher end frequencies are behaving like a light rays. So they can be used for astronomical study. They can travel in straight lines. So directivity is more, so less beam width, and it will travel for longer distance. They can penetrate through fog, smoke, clouds, and ionosphere, so they are used in astronomical research. The advantages of microwaves are increased bandwidth availability. As frequency increases, bandwidth decreases, so more and more bandwidth is available for communication. And improved directive properties, as because of it is a high frequency signal, the high frequency, as the frequency increases, directivity increases and fading decreases, and this signal is more reliable signal. The power required for the microwave signal generation is very small, comparatively small. The transparency property of microwave, that is, the higher end frequencies of microwave signals will behave like light rays. So because of this transparency properties, it can be used for astronomical study. Microwaves also have some disadvantages. They have complex circuits, the measurement is difficult, and line of sight propagation will limit the usage. There are numerous applications of microwaves. They can be used in telecommunication industry. For intercontinental communications, we can use microwaves. For space communications, for telemetry communication, for the link for the railways, we can use microwaves. In the radars, it is used for detecting and tracking the missiles. It is used for observing the weather patterns, air traffic control, burglar alarms, garage door openers, and police speed detectors. Microwaves are used. There are many commercial applications of microwave like microwave oven. It is used in drying machines for textile, food, paper, drying clothes, potato chips, printed matter, textbooks, those things we use microwaves. For food processing industry, like for pasteurization, sterilization applications, we use microwaves. In the rubber industry, we use microwaves. For mining and public works, breaking the rocks, creating the tunnels, canals, we use microwaves. For drying inks, drying textiles, sterilizing things, we use microwaves. And for biomedical application, especially diathermy and hyperthermia, Diathermy is localized superficial heating, and hyperthermia is a part of cancer treatment. So microwaves are used. The other applications are these things. They are used for detecting the personal by non-contact method, and they can be used in many microwave devices like jitter-free switches, phase shifters, etc. We know that this is an electromagnetic wave. Now, this wave, the blue line, indicates the magnetic field. If the magnetic field is the blue line, obviously this pink or the red lines indicate the electric field. This is an electric field wave. And we can observe that the magnetic field as well as the electric field both are mutually perpendicular to the direction of the propagation. And this is one complete wavelength from this point, from the start of the signal until the end of this wave. This is the wavelength of the any signal. So we know that an electromagnetic wave will propagate in this manner. The various bands available are for communications are ultra low frequency, extremely low frequency, super low frequency, very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, extremely high frequency, infrared region, visible light, UV rays, X-rays, and gamma rays and cosmic rays. We can see that 1 giga to 1000 giga, that is ultra high frequency, super high frequency, extremely high frequency, and some part of infrared region will come under microwave frequencies. Now, I want to ask a question. What is the microwave frequency range and why it is called so? That is, why a microwave signal is called microwave. Dear students, please think about this answer as we have already discussed in this class. Now, I want to give the answer. The microwave frequency ranges from 1 giga to 1000 giga, and because they are having high frequency, the bandwidth is very small, very as low as 0.3 mm. That's why they are called as microwaves. Thank you for listening to my class. Enjoy with microwaves. We'll meet in the next class.